Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Today, let us solve a problem involving two currents. And this is in a function of time. So to illustrate, we have here a branch connected to this node. For instance, this is node N, and another branch, and this is another branch. So currents flows through here, through N. Let's name this as I sub 1, and another current I sub 2. Okay, so when it goes out here, this will be I sub t. So therefore, the resultant current is simply as I sub t is equals to the current I sub 1 plus I sub 2. Okay, so here we are given the values of the currents. I sub 1's value is 12. This is sine 2 pi 60 t, and this is added to I sub 2 value, which is 9 cosine 2 pi 60 t. Okay, and actually our omega here, we can have our omega, which is 2 pi 60. And if you are going to use your calculator, what is the 2 pi 60? Okay, so 2 times pi times 60, okay, equals, that is 376.99, or if we are going to round it up, this is 377. That will be our omega. Now we have a general form that by the way, this is I. Okay, our general form is that we have a squared plus, okay, b squared. Okay, you take the square root of this one and then sine omega t plus theta. So this will be our general form, knowing that this form is also in, okay, let me have it, this is the form. This also is of the form, okay, a sine omega t plus b cosine omega t. Okay, so we just have to get for the value of theta, and theta is actually the inverse tangent of our a and b. Okay, so we have here the value for theta, which is our b over a. Okay, so that will be our value. Okay, now we can right away get the value for theta. Okay, so we can set up a figure here, a right triangle in which our b is here, our a is here, and this is our c, and this is the theta. Okay, so therefore, since that we have a given value for b and a, which is identified here as this one and this one, we can right away get the value of theta, and theta is the inverse tangent of 9 over 12. Now, if you have your calculator, okay, so the inverse tangent, hope you are seeing this one. Okay, the inverse tangent of shift, inverse tangent of 9 divided by 12. Okay, and it will give us 36.86. Okay, 0.8698 or 36.87. So this is 36.87 degree. Okay, and so we can easily get the value of our IT or the total current. Since this is of this form, this one is of this form, so we can have this form already because we have already values for A, B, and omega t and theta. So that simply gives us A is equivalent to 12 squared plus 9 squared, and sine omega is 377t plus theta, which is 36.87 degree. Okay, so what is square root of 12 squared plus 9 squared? You have your calculator again, you press your calculator, it will give us actually 15. Okay, and that is sine 377t plus 36.87 degree. Okay, so this is our I total. So this is what we are looking for, the resultant current. Okay, so the other question here is the RMS value of the resultant current. So this is the resultant current, and this one in our form is the peak value or the maximum value. So to be able for us to get the RMS, by the way, this is for question that one, let us name this as A, and for our letter B, since this is the peak value, so we just simply get the RMS value for our total current. So how do we do that? So that will be the peak value multiplied by 1 over square root of 2. Okay, so therefore that is simply as 15 times 1 over square root of 2, and by having your calculator, you have 15, okay, divided by, okay, square root of 2, and it will give us 10.606 or 10.606 or 61 ampere. So this will be the RMS value. Okay, so that's how you solve for the total currents and its RMS value for this problem. So thank you so much for watching this video. Hope you share this video to your friends.